best properties in Monopoly aren't the most expensive ones. They are the ones hiding next to the jail. Most people spend their entire game chasing Boardwalk and Park Place. It makes sense also, right? They are expensive, they charge huge rent, so they must be the best investment. I mean, it makes sense, right? Not according to the math. Mathematicians have been analyzing Monopoly for decades now, and when they built models to see which property players land on most often, one color kept showing up on the top. Orange. St. James Palace, Tennessee Avenue, New York Avenue. To understand why, forget the properties for a second, okay? The most important square on the board is actually jail. You can get sent there by landing on go to jail, you can get sent there by a chance card, or by rolling the doubles 3 times in a row. No other square has that many ways to reach it, which makes jail one of the most visited locations in the game. Now think about what happens when players leave the jail. They roll 2 dice, and 2 dice don't behave the way most people think. There are 36 possible combinations, right? Only one way to roll a 2. Only one way to roll a 12. 6 different ways to roll a 7, making 7 the most likely outcome. And 6 and 8 are very close behind it. So, the researchers asked a simple question. What happens if we count 6, 7 and 8 spaces from the jail? You land on, yes, you guessed it right, St. James Palace, Tennessee Avenue and New York Avenue. The orange properties. Players keep getting pulled back to jail. The dice keep sending them back to the 6, 7 and 8 spaces forward. And the orange properties sit right in the path. Not because they are the most expensive, not because they have the highest rent, because the probability keeps delivering players to them. The tool behind this analysis is actually called a Markov chain. This is named after a Russian mathematician called Andrei Markov. More than 100 years ago, Markov developed a way to study systems that move from one state to another. In Monopoly, every square is a state. The model calculates the probability of moving from one square to the next and repeats that process over and over again. When researchers ran Monopoly through that model, the board stopped looking random. Patterns started appearing, and one of the strongest patterns pointed straight at orange. This isn't just used to analyze board games. Insurance companies use Markov chains to model how customers move between different states. Example, active policyholder to renewed policyholder. Active policyholder to a lapsed policyholder. By estimating those probabilities, insurers can predict future claims, estimated reserves, and understand customer behavior. The same mathematics that tells you where Monopoly players are likely to land. Insurers predict what millions of policyholders are likely to do next. Monopoly feels like a game of luck, isn't it? But underneath it, there is a pattern. And once you see that pattern, it's hard to look at the board game same way again. So follow Beyond Numbers with Rishti for stories where mathematics explains the world around us.